Good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 44 is on the screen. Let's stay focused, please. Today I'm going to do a quick recap on what I left on Wednesday, Friday of last week, just to make sure everybody's on the same page, because we're about to lock in. I'm going to show you a couple of calendars to see where we're at with the semester, so you know exactly the pace that we're going to be headed towards. So make sure you stay on top of your stuff, please, pretty please, with the cherry on top. So warm-up 44 is on the screen. Number 1, find the measure central tendency. Number 2, find the standard deviation and bell curve. Copy and go. All right, being that it's Wednesday, first day of the week, I'm going to go over this really quick just to make sure we got it. For number 1, measure central tendency, reminder, we have mean. We use two types of symbols, mu and x bar. The second one is median, or also known as what? Q2, and mode. All right, so let me write these in order. 1, 2, 3, 4, and 5. So the mean, it looks like, let's see, 9, 10, 15. Divided by 5, that is 3. Hands if you got 3. Median 3. And mode, none. Okay, we good? Yes, MCQ. All right, from there, compute the standard deviation. Oh, a box plot, my bad. Box plot, we got 1. Our Q2 is 3. Q1 is 2. Q3 is 4. And our max is 5. So, something like that. Go to number 2, standard deviation. 1, 2, 3, 4, 5. The mean was 3. So we subtract 3 from all these. So we get -2, -1, 0, 1, and 2. Square those. Now, mind you, these I know how to do in my head by now, which I'm assuming some of y'all the same way. So this is 4, 1, 0, 1, 4. Therefore, see what I did there? 10 divided by 5 is 2. And our standard deviation, or our sigma, is square root of 2, which is 1 point, what is it? 41? 41. All right. Bell curve. By now you know that the mean goes right down the center. And one standard deviation up would be 4.41. Mean is 3. One standard deviation down is at 1.59, and that's the norm. All right, copy the agenda, please. Warm up 44, actually it's 47, my bad. Warm up 47. 47. Since I left you 2 video lessons, right? Yes, Mr. Q, thank you. All right, you're welcome. And measure the variation, and we're going to run it back. Home plate, page 143, numbers 1 through 8, evens only. I'm going to show you that in a little bit on the screen. However, as you're finishing that up, let me go to the calendar. So here goes. Y'all ready? So for this week, we only have today, tomorrow, and Friday. So that's 3 days. And today pretty much is going to fly by. You're going to see in today's session. Tomorrow, more practice on that, because I want to make sure that we got all measures of variation. And Friday's coming. You see, you've been practicing this forever. Next week, we have from the 17th to the 21st, and then from there we're off. Is everybody following so far? So once again, only this week 3 days, next week 5 days. Let's go to December. Look up. In December, we're going to do a review, look up, the first week of December of everything we've covered from the beginning of the school year. December 8th through the 12th, we're going to have our semester final. You will have a cumulative final here of everything we've covered. Like that, that's going to give me time to grade and have grades for you before you leave on vacation as a Christmas gift. There you go. Is that good or what? All right. Like I said, time's flying and you guys need to be on top of things. Okay? All right. Give me a second. All right. Copy the access code for the home play. Oh, give me a second. It's frozen. Let it go. Let it go. Oh, you guys heard that song? Oh, thank you. Appreciate it. There it is. 4T5QU. Write that down. 4T5QU. 4T5QU. Going once. Going twice. All right. So, this is a home plate. I'm going to give you plenty of time. Hopefully, at the end of the session before we leave, you can finish as many as you can. All right, here we go. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. Write that down. I can summarize data and compute the measures of variation. Now, on the video lessons that I left you, I gave you this introduction, and hopefully you have the notes. I'm just going to go through it one more time to make sure we're on the same page. And I'm going to be calling on some of y'all to help me out. Okay, we good over there, Adrian, Moses? Good? All right. So, with that said, measures of variation, what are they? Here it goes. You already have these notes. You don't have to write these down. You have these. However, remind your neighbor, what are the 3 measures of variation according to the notes you took last week? What are the 3 measures of variation? Looks like Enrique's on the ball. Very good, Enrique. My goodness. Yes. All right, so Haiti says range, standard deviation, and Levi's got the last one because he's locked in. The 3 measures of variation. Haiti said range, standard deviation, and you're just missing one. The variance, that is correct. However, the definition says commonly used measures of variance for a set of numerical data that represent the spread of the data. No. Now here, look up guys, on the definition, the key word here is spread. So with these kind of measures, we want to know how the data that we're focusing on is spread out in the center. However, yes, the 3 of them, once again, range. This symbol right here, the sigma, is standard deviation. But when we write sigma squared, that's variance. Variance. Once again, what is it called? Variance. All right? Why are these not measures of variation? Because these are the measures of central tendency, mean, median, and mode. All right. Copy this down, please, on your notes. Data measures. Central tendency. Variation. And position. Write those down, please. I'm sorry? Oh, yeah, we got this. And once again, reminder with those mobile devices. Measure central tendency, measures of variation, and measures of position. That's where we're headed. So, underneath measure central tendency, write what they are. We're going to have Adrian help us out. Measure central tendency are? Bless you. Mean, median, and mode. That is correct. Now let's go to measure the variation. Pass them on, Adrian. Who? Lucas. Standard deviation. Standard deviation, range, variance. That is correct. All right. So we're in the middle of variation. We're headed towards position, and we're going to wrap this up together, the whole thing. Hopefully we got this. Like I said, Friday's coming, and by now you should be experts at central tendency and variation. But today I'm going to give you an extra day of practice. All right? Everybody got that yet? All right? So, with that said, formulas. In the video I said there's 2 more formulas that we're going to add after the 7 that we have, and here they are. Look up. Standard deviation and variance. Is that correct? However, the video did not show these next 2. Look up. It did? Oh, okay. Oh, my bad. All right. So, make sure you have those 4. And tell your neighbor the difference between the top 2 and the bottom 2. The top 2 and the bottom 2 that we just added. Talking to your neighbor. Then Luke is going to pass them one so they can elaborate on that. All right, Lucas, pass someone. Go with who? Enrique. All right, these 2 represent what? What? Help him out, Aaron. Sigma, okay, to start with this one, what does that represent? What is it? He said population standard deviation. Deviation. So this was population standard deviation. So what is this one? According to the notes that you took. Pass them on, Aaron. Enrique. Population variance. Variance. Okay, now that we have those 2, what do these 2 represent? Tell your neighbor, what do these 2 represent? Enrique, pass them on to the other side. Sam, what does this one represent? Standard deviation, okay. So far so good. But what does the S? Sample, that is correct. Sample standard deviation. So therefore, what does this one represent? Pass them one, Sam. Ezra, what does this one represent? Sample variance. Hands if you got that. That is correct. Now, look up in case you didn't see the obvious. If this one is population variance and this one's sample variance, what's the difference from one formula to the other? Look at it. What are the differences? Talk to your neighbor. What are the differences from this formula to this formula? Talk to your neighbor. Differences. All right, Ezra, pass them one. Gio, what's the difference from this one to this one? Should have 3 differences. The S, okay, yeah. So S for sample, and we use the sigma for population. What else? The N, small n for a sample, big N for population. What else? Yeah, the mean. Mu for population and X bar for sample. That is correct. If we go to standard deviation, it's the same formula, but with a square root. Everybody got that? Yes? Make sure you get this down because, like I said, we're about to embark on partes on formulas. We need to know each component and what they are. All right? So, with that said, copy this one on your paper. Example Q. Compute the measure of variation. 1, 9, 3, 10, 7. Just copy the numbers. 1, 9, 3, 10, 7. All right? And before I get started, tell your neighbor what are the measures of variation? Again, what 3 measures of variation? All right, I heard range, standard deviation, and variance, which is standard deviation squared. Okay. All right, what'd you get for the range? Let's go with Geo. 9. And if you got 9, that is correct. Highest minus the lowest. Let's go with standard deviation. I'm going to use the process to make sure we got it. So first I'm going to get all my numbers, or all x's. 1, 3, 7, 9, and 10. And the first thing I do, since this is a sample, I'm going to find the mean, which is x bar. So this is 10, 20, 30 divided by 5. Mean is 6. So far so good, yes? Yes, Mr. Q. All right, next we take x and subtract the mean. So we take 1, 3, 7, 9, 10 minus 6. And we end up with, this is negative 5, this is negative 3, 1, 3, and 4. What do we do with that? Oh, we take x minus x bar and we square it, Mr. Q. Okay. So I'm going to square all those numbers. So this is 25, 9, 1, 9, 16. What do we do with that, everyone? Remind your neighbor, what do we do with that? Add them and divide them by 5, is that correct? Which means find the mean. But in this case, look up, we're going to call it, tell your neighbor what that is. What does S squared mean? Sample variance. That is correct. So, let's do that. So I'm going to write it on top. I'm going to take x minus x bar squared. I'm going to find the sum, which is the big sigma, and then I'm going to divide by the number of numbers. So, let's see. 25 plus 9 plus 1 plus 9 plus 16, that's 50, that's 60 divided by 5, that's 12, is that correct? 12. Our last step, what do we do with that to find our standard deviation, everyone? Take the what? square root. So check this out. The next column is the sum of x minus x bar squared over n, and we take the square root to find our sample standard deviation. So therefore, we take s squared, which is 12, take the square root to both sides. So our standard deviation is approximately square root of 12. 3 point what? 46. And that's how we get our formula for standard deviation, and that's how we get our formula for variance here. Just following the process. Good question. So your colleague asked, Mr. Q, how do you know to use the S or use the sigma? Well, whenever you only have 5 to 10 numbers, which is a small amount of numbers, you use the letter S. Whenever you have more than 10 numbers, you use sigma. Did everybody hear that? Let me repeat that again. You use the letter S squared or S when it's 10 or less data. How many numbers did we start off here with? 5. So that's why I use the letter S. However, if it's more than that, you're going to use sigma square or sigma. All right? From 1 to 5, I'll come to you with this. Yeah, we got it. 5, 4, 5, 4s. And some of you are like, Mr. Q, I'm still iffy on this, but we've been doing this all year by now. The only thing now, I'm just showing you the formula on top. Did everybody see that? All right. All right, before we move on, look up. This one. They're asking us to compare 2 different brands of paint. And this was on the video. I'm not going to go over this again. However, how many data do we have for brand A? There's 6 of them. So what formulas are we going to use? Let's see. All right. So I'm going to use the letter what? S. So S squared. Let's see. What is the formula to find the variance? Let's see. Think about it. Try not to look at your notes. What did we do at the end to find the second mean? We found the sum of what? Of x minus x bar squared. Is that correct? And then we divided by n. And then at the end, to find the standard deviation, all we do is take that and we take the what? The square root. Do that for one brand, you do for the other, and at the end you compare. We're not going to do that, but you already did that on your notes. So without further ado, you have exactly 25 minutes for you to work with a partner to work on numbers 2, 4, 6, and 8. 2, 4, 6, and 8. Those of you following on YouTube, hopefully this will give you plenty of practice. Copy and go.